Hello and welcome to PCMINR.com, and you're watching this video on SAT Physics questions and their solutions by Sonal Gupta. So a question says 3 charges 10 microcoulomb, 5 microcoulomb and minus 5 microcoulomb are placed at the corners of an equilateral triangle. The side of the triangle measures 10 centimeter. So out of these 5 given options, what is going to be the resultant force on the charge 10 microcoulomb? So let's find out how we can find the total force or the resultant force on the charge of 10 microcoulombs. So here we have the equilateral triangle ABC, and the charges are placed like this, that we have a 10 microcoulomb charge at A, a 5 microcoulomb charge at B and negative 5 microcoulomb charge at C. So the force that B would exert on A would be a repulsive force because both of them are positive charges. So let's say that the force exerted is along BA because it's going to be repulsive, and the force exerted by C on A is going to be attractive because the charge at C is negative. So that force is going to be along this direction. So we can mark the points as AQ and AP. So now the angle between the forces, let's mark this as FBA, the force exerted by B on A is along AQ, and let's mark this as FCA, the force exerted by the charge at C on A. So first of all, what are the values of these forces? So we have FBA is equal to, so by Coulomb's law, it's going to be 1 upon 4 pi epsilon naught QA, the charge at A, times QB upon AB square. So we just substitute the values and we get FBA as, so 1 upon 4 pi epsilon naught is 9 into 10 to the power 9 times the charge at A, that's QA, is 10 microcoulomb, so it's 10 into 10 to the power minus 6 into 5 times 10 to the power minus 6 as 5 microcoulombs, and upon 10 centimeter is 0.1 meter, so 0.1 square. And when you solve this, you would get a 45 Newton of repulsive force, right? And similarly, we can find out FCA, the force on A due to the charge at C. So using the same formula, and all the values are also same, it's just that this force is going to be 45 Newton attractive force because the charge at C is negative. So we get these two forces, FBA and FCA. Now these two forces are inclined to each other at an angle of 120 degrees because this is an equilateral triangle, and the exterior angle is going to be equal to the sum of opposite to interior angles, and each angle in an equilateral triangle is 60. So therefore the sum of these two is 120. So this angle is 120. Now using the formula for the resultant force, that we apply the vectors. So let's find out the resultant force using the values as 45 Newton, 45 Newton and the angle of 120 degree between them. So using the formula for the resultant, which is for two vectors, is a square plus b square plus 2ab cos of theta. So resultant force on 10 microcoulomb is going to be 45 square, that's the first force square, plus the other force is also 45, so 45 square, plus twice of AB, that is also twice of 45 and 45, and cos of 120. Now we have the same thing in the next equation, so just taking all the things to be same, so we just substitute the value of cos 120 to be minus 1 by 2, and now this 2 would cancel out. So you are left with square root of 45 square plus another 45 square, and the third one is minus 45 square because this minus sign will get multiplied and you get 45 into 45 is 45 square. So this would cancel out and you get your answer on solving the square root as 49 Newton. So that's your resultant force which acts on A, or the charge at A due to the charges at B and C. Therefore, your correct option is A, that's 45 Newton. I hope you found this video helpful. If you like our video, please subscribe to our channel and follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.